Programmability. This is tools and developer experience for tell us why you want to move money. An interesting way to think about programmability is maybe an hourglass. You send a bunch of money in, API, SDK, MCP, CLI, stuff happens, secret sauce, nuclear fusion, and the money comes out exactly how you need it to come out. And so let's talk about, there's different, this is like a bundled perspective. There's different types of programmability. Our kind of most powerful tool and product that's actually coming out this quarter is something called programmable transactions. Programmable transactions allow you to encode very advanced on-chain logic, price risk management, limit orders, maybe like whitelisted liquidity requirements, math that you want to do across on-chain liquidity at the instant that you're transacting. You can encode really advanced logic in a transaction itself. You don't need to deploy a smart contract to control it. You can just sort of encode your strategy as a developer with an API or a simple JavaScript SDK and ensure all or nothing execution against your advanced strategy. Really, really good if you want to kind of use it in a very hands-on way. Great for kind of sophisticated on-chain liquidity managers like vault curators, for example. Maybe with a higher degree of abstraction, using it through an API. Very good for advanced off-chain liquidity managers that want to do stuff on-chain, like a treasury manager. So that's programmable transactions. Maybe one subset of that is programmable addresses. So let's talk about that particular use case. Programmable addresses. So programmable addresses allow me, as an app builder, to say, well, I'm building for some crypto-enabled use case. I want people to be able to deposit into my application with particular rules, or to pay out of my application particular rules, but I'm gonna talk about deposits in this particular case. So let's say I'm building Phantom, and I have my own stablecoin. We've called it Cash. This is real, at least insofar as they have their own stablecoin. I want to enable my users to have a Phantom-specific address in human-readable form that accepts major stablecoins from 10 different directions and automatically settles them in Cash in Phantom. That's what I want. I want to incentivize people to hold that asset. I want to reward them for doing so. I want to make it as seamless as possible for them to choose to hold it. And so with programmable addresses, I might be able to say, I can enable Rhine to claim Rhine.Phantom.xyz, say, like a sub-address. This is my domain-specific address. It maps to a particular on-chain public key. In this case, it's going to be a Solana program. And I want to allow Rhine or any of Rhine's friends to send USDC or USDT from any chain. USDC on Base, T on Arbitrum, T on Ethereum. And as soon as it hits my programmable address, it lands as Cash on Solana. And Ryan didn't have to do anything except provide his address for somebody to send supported funds to. A hot swap happens right here, and a settlement goes into the application. This is a pretty simplistic use case. It's like, this is just good UX. It's like not mind melting here, but it's a good example of kind of, if you're building an app on chain, you've had these artificial constraints of saying, I have to choose a chain. And I have to default my users to that chain, and then I need to integrate a bunch of interoperability infrastructure to allow them to find me and to use my product. No, we just build an incredible front end and really good mid layer for however you want to manage your features, and leave the money movement to us. So this is a very simple use case of kind of lower level programmability technology, but it's one we see quite a bit of demand for, just to get your application's sort of user experience to parity with common fintech product. And so that's kind of like a subset of that. And then if you put it all together, you end up with a rocket ship.